Hi guys, I hope you're good, I hope you're well and excited for our first lesson on exponents today. And we will be specifically looking at the exponential rules and laws, and we're going to also review some of those laws, and we're also going to be working with the rational exponents. So I hope you are very excited for this lesson, and please grab your pen and paper. Let's do this. So the first part of our lesson looks at explaining exponents in our everyday life. So exponential notation is a short way of writing the same number multiplied by itself many times. This is very useful in everyday life. You may have heard someone describe the size of an area in square meters or square kilometers. For example, the largest radio telescope in the world is being built in South Africa, and the telescope is called the Square Kilometer Array, or the SKA. This is because the telescope will occupy an area of 1 kilometer by 1 kilometer, or 1 kilometer squared. So exponents are also very useful to describe very large and very small numbers. So we make use of exponents to describe very huge numbers and also to describe very small numbers. So for example, the SKA will be detecting incredibly weak signals from objects which are so far away that to write out the strength of the signal or the number of kilometers away in full worlds would be impractical. And outside of astronomy, exponents are used by many other professions such as computer programmers, engineers, economists, financial analysts, and biologists. So we will make use of exponents in different ways. So we can make use of this to represent very small numbers and also to represent huge numbers. So that is why exponents are very important, because they will assist you in writing. It's like a numerical summary. That is how we use it here in mathematics. Okay, so I have to first break down how we actually interpret values that have exponents on them. So whenever you see, usually it's the coefficient, but a value that has an exponent or a power up, we call it the base. So if I have 2 to the power of 3, 2 is the base, 2 will become your base, and 3 will become your exponent. So sometimes it's called the index, but here we will use the word exponent a lot. Okay, so the power or the number raised up, we call it the exponent, and the number carrying the exponent, it's called the base. And also we need to look at the laws of exponents that we have. So we need to remember the following identities. So we've worked with exponents briefly in the previous grades, grade 8, grade 9, but you didn't go deep with them. So now we'll revise a few laws of exponents and also give you more of these rules. Okay, so the first part is, if you have a to the power of n, so it means you have a times a times a times to the power of that value. So it means if I have 2 to the power of 3, I simply have 2 times 2 times 2. So I repeat the base to the number that is written on my exponent or on the power. And the second law is, if you have 8 to the power of 0, every value to the power of 0 is 1. Okay, so every value to the power of 0 is 1. So a, you must never write a as 0, because 0 to the power of 0 is undefined. So if I have 2 to the power of 0, just know that I have 1. If I have 1000 to the power of 0, just know that is 1. Okay, so that is another law of exponents that we need to always look for. And then the second part, the third law says a to the power of negative n will be given by 1 over a to the power of n. So we need to always ensure, if I give you 2 to the power of negative 1, I can write this as 1 over 2 to the power of 1. So we need to ensure that our exponents remain positive, and to ensure that our exponent remains positive, we introduce a fraction, so it becomes 1 over 2 to the power of negative or of positive 1. So the same thing happens if you want to go to the opposite direction. So if you find yourself with 1 over the negative exponent, so you need to make sure you have an inverse of that. Okay, so that is how it works. Now the laws of exponents kept on adding and adding and adding and adding. So I will be also breaking down for you what these other laws really mean on exponents. So I have this law that says if you have a to the power of m, you multiply it by a to the power of n, it is the same as a to the power of m plus n. So guys, in simple terms, I'm saying if you have the same basis multiplying, okay, you simply add the exponents. So if you have 2 to the power of 3 times 2 to the power of 5, this simply means you have 2 to the power of 3 plus 5. That is why the answer is 2 to the power of 8. So if the bases are the same, just add the exponents. And when you go to the second part, remember multiplication and division, they are inverses of each other. So now we are dividing. If you have a to the power of m divided by a to the power of n, remember the bases are the same, guys. You simply subtract the exponents. So if you have 2 to the power of 6 divided by 2 to the power of, let's use 2, you simply have, you take one base and subtract the exponents. So that is why your answer will be 2 to the power of 4. And the third law also, if you have a bracket that has values inside a, b, and the exponent n, you simply distribute the exponent to both values. So if I have x, y to the power of 2, I have to distribute 2 into both sides. So this is going to be x to the power of 2 and y to the power of 2, because I need to distribute every value there. The same concept applies when values are dividing. So as you see there, we have a over b all to the power of n. So it is the same as a to the power of n divided by b to the power of n. This means that if I have x divided by y to the power of 2, I have to distribute this exponent to both values. So this will be x to the power of 2 divided by y to the power of 2. And lastly, we have one more law that says if you have exponents inside, if you have one exponent inside the bracket and another exponent inside the bracket, you simply multiply the exponents together. So if you have a, this one says a to the power of m, a bracket n. So let me just give you another example. So if you have x to the power of 2 and you have a bracket there and you have another power that says 3, so you simply have x to the power of 2 times 3. Sorry, 2 times 3, not 60. So it's 2 times 3. So that is why you have x to the power of 6. Okay, so that is how you work with the laws of exponents. So these laws and the previous laws that you just saw, those are the most important laws that you need to use every time we're dealing with exponents. So now let's go to the rational exponents and surds. So if you're looking at the rational exponents and surds, you need to first understand how to break down the square root value. So the square root, if you're looking at the square root, you have a degree there given by the letter n. So you have the degree and you have the radical sign. So the radical sign is actually the square root, okay, the square root sign. That's what we call it most in our everyday language, but it doesn't just represent the square root, it can also represent the cube root, the fourth root, the fifth root, right? So that's why we call it the radical sign. And we also call the value that is underneath that root sign, it is called the radicand. So we call it the radicand, and it's given by the letter A there, okay? So that whole scenario that is happening there, it's called the radical. So we call everything that is the radical. So the laws of exponents can also be extended to include the rational numbers. So we've worked with a number of laws of exponents, but we can extend them to include what? Rational numbers. A rational number is any number that can be written as a fraction with an integer in the numerator and in the denominator. So we can extend that, and the laws that we find are as follows. So we have the following definitions for working with rational exponents. If r to the power of n equals a, so if r to the power of n equals a, then r equals to n. So that radical sign is introduced there, and the degree now, which was the exponent, lies on that value there. So and then you have the root sign, and you have a, which will be your radicand in that case, and a must always be greater than or equals to 2. So it can never be less than that value, okay? It's always greater than or equals to 2. So if you have a to the power of 1 over n, so you have a fraction there, this is the same as a as the root, the nth root of a. What do I mean is, if I have, let me just use actual values. If I have 4 to the power of 1 over 2, this is the same as the square root of 4. So remember, guys, we hardly put the 2 there in that space, but that 2 simply means square root, okay? So usually just get things written without the 2 there. So that is what that first law of rational exponents means. And the second law says that if we now have a negative power, remember from the first law of exponent that if you have a negative power there, we must make sure that it becomes positive by introducing a 1 over that value. And also now, because we are now working with sets, it means that degree must now be in that space there. So if I do an example with this, I would choose an example of, let me still use the 4, but now let's say I had 4 to the power of negative 1 over 2 now. So it means I have to make sure that I write this as the square root of 1 over 4. Because my exponent was negative, it means a 1 now must be introduced. So the moment you find a negative exponent, just know that you are working with a fraction automatically, okay? Now let's go to the next one. So if you have a to the power of, so m now is a number greater than or less than 1, and divided by n. So you already know that once you have such a case, you are now working with a root there. But the value of m is a numerator, so it will always be attached to a. As you can see here in our example, because we had m to the power a to the power of m over a over n, so m also comes back there. So if I give you a practical example, let me just use a different number this time. So if I use 9 to the power of 3 over 2, this simply means I have the square root of, so because the 2 simply means the square root, but let me just write it there, and then I have 9 to the power of 3. That's what it means, okay? So it means the numerator needs to always go back to the position it has to be with, with the actual value that we are working with. Okay, so guys, the following laws that I gave you, I've given you the laws of exponents, and I've also given you the rational exponents and sets law. So you need to always go back to all of these laws, because in the next few lessons we will need to make use of all of these laws. So guys, thank you for joining me in this lesson today, and I will see you on the next one.